Hello, everyone. Thank you for joining my session. My name is Michal Brygidyn. I came here directly from Poland to tell you about my security research. I'm an AWS community builder and AWS ambassador, and I work as a cloud security architect, but that's not what I will be talking about. In the evening, when I have some time, I wear a white hat, and I try to get admin access on your AWS accounts. And this is what I will share with you today. Let's start with something quick and easy. First scenario, HTML. How to hack into someone's cloud using just HTML? This is a trivial scenario because you just need to view the source code of a website. And if you do so, you can find things like that. Just HTML, an HTML comment left by one team for another team saying, hey, this is part of a configuration file with valid AWS credentials, access key and secret key. Please remove before production. As you can see, this is production, and it's pretty easy to find it. What's the next step? There is no next step because these credentials already gave me access, and this user, IAM user, had administrator access policy attached. What went wrong here? Sensitive data left in the code. So there was no problem in the cloud itself. The problem usually sits between the chair and the keyboard. So the team that created this code, that developed this code, left configuration, part of the configuration file, the credentials in the code. They pushed it to repository, and they thought that it's a great idea to leave it there because, hey, next team will pick it up and they will clean it. So they forgot to clean it. Next scenario. Do you guys use GitHub? So GitHub was like an El Dorado for security researchers up until May last year, because in May they changed the search engine. But before they changed the search engine, you were able to look for anything you wanted and sort it by indexed date. That means that if you just pushed something to a public repository, I was able to find it immediately. Now it's not that easy, but still you can find interesting things in public GitHub repositories. So this scenario starts with one of public GitHub repository, and this is an example of what you can find there, like credentials for databases, for mailers, connection strings with username and password with access keys, tons of credentials there. Now it's a bit harder to push sensitive data, to push credentials, because GitHub prevents you from doing that unless you are smarter than GitHub and you encrypt your credentials, the values of a config file. But yeah, let's go to it. So I found a public repository with a config file that has encrypted values. Something interesting, something different than the tons of plain text credentials. And when I was checking the repository, there was also a Java file with the whole encrypt, decrypt functionality, the logic. And also, there was the encryption key hard-coded in this file. I'm not a Java guy, but hey, Google run Java online. So I found a way to run this online. I put these encrypted values there, and all config values got decrypted for me. So next step, we are not going directly to AWS. This one is a bit more complex. I found the email and password for Office 365 account. And if you have access to Office 365 account, I don't know if you're using Office 365 in your work, daily work, but if you have access to a user with licenses for Teams, for example, You are able to check the organization tree. You are able to just send a message to C-levels, hi, I'm a hacker, or something like that. But you also have access to SharePoint. That's the place where you look for data. And many teams are misconfigured in a way that they are public in the context of a company. But I already have access to a valid account in that company, so I have access to all public resources in SharePoint, including a PDF with a full Jira configuration guide, step by step. When I asked later why it's there, they told me that a team of junior help desk administrators, they were asked to install Jira and put every single step in a file for their supervisor to check what they were doing there. So this is what they did. Every single step, including the last step of creation of superadmin on Jira with username and password. Thanks to that, I had access to Jira of that company, but hey, where is that Jira? This was easier than I thought because it was jira.example.com, public endpoint, and I already had a username and password for that superadmin, so I just logged in. And I don't need the data of that company. I don't need any other access. I'm looking for AWS access. So when in Jira, hey, give me all projects with AWS in the name. There were some, and in one of the projects, there was a task. We need IAM user and access and secret key for our external tool to communicate with AWS. And there was a comment to that task. Here you go, there's access key and there's a secret access key. That easy, admin access starting from public GitHub repository through Office 365, Jira, finally AWS. Many small misconfigurations linked together, chained together, gave me access to someone's AWS account. What was the problem here? First of all, hard-coded credentials. Like Peter said on Keynote, I'm the one who finds your credentials. And if you are sending your credentials to repositories, not only repositories, but to public endpoints, public places, there will be someone who will find it. And there's also one more thing with repositories. Git remembers. So if you push your credentials and then you find out, okay, I made a mistake, there's a problem because my credentials are in the repository, and you just override them with the current version of the code with some dummy values, be sure that I will check history as well. So not only override the values in your current version, but also invalidate those keys, rotate those credentials, etc. But tools selection. The team that was creating that tool, they used public GitHub repository because they were not developers. They were administrators of a company, wanted to automate their work, and that was the first thing they found. So they use that. And yeah, the biggest problem, lack of security awareness. Why it is a problem that we put username and password in a file that's available for the whole company? We are working for the same company. Hey, I'm not, but I just got access to your file. Next scenario is a Symfony profiler. Who works with PHP or worked with PHP? No one. Okay, nice. Symfony is a PHP framework, and profiler is a development tool that helps you develop app in Symfony framework. And it helps you by showing you the configuration of a server, by showing you the history of all requests that you make to that machine, to that application. And also some versions of Profiler allows you to preview contents of files in the project directory, including files like parameters YAML. If you find public and available for all Profiler, you can find things like environment variables. And as you can see, we already have S3 secret and S3 key here, but it's only access to S3, so only some files, maybe even sensitive files, but I'm not looking for data, I'm looking for full admin access. So then we have our requests, a history of all requests to that app, including post requests, and post requests to login endpoint with plaintext variables, parameters. So we have plaintext login and password to some app. This is, of course, a non-production application, but when you find something on a non-prod environment, you usually try if the same set of credentials work for production environment. This was like dev.example.com. I logged in. OK, I'm admin there. But what happens if I remove dev. and just log into example.com? It also worked. The same set of credentials worked for production environment. And it was some kind of internal app with many different tiles to click with SSO, single sign-on, redirecting me to other systems like production CRM. But I'm not looking for data. I'm looking for AWS access. So there was a webmail. When I opened webmail, I found a lot of emails from AWS Trusted Advisor, emails with AWS invoices, and this gave me an idea. Hey, maybe this is a root user email. And on that stage, I was already in contact with CISO of that company, and I told him that I have admin access to the internal app. Should I continue, or you want me to stop and fix it? And he said that his company has a procedure, and they should be able to find out that I'm inside, that I'm using one of the compromised accounts. And he told me that I should try to get access to AWS. Whatever I need to do, I should do it without breaking the whole production. But he let me continue my research. So I went to the login page of AWS and hit on I forgot my password link, and provided that email from that webmail. And the link arrived. So I tried to reset the password of that user. It was also successful. And that's where I should be stopped by MFA. But guess what? There was no MFA. So using my new password and the email, I logged in. And it was a jackpot, because it wasn't a standalone account. It was the management account for the whole organization of that company. When I sent my report to CISO, he said, OK, we're done. Let's talk about bounty, but please do not go any deeper. We have no idea that you are there. Our team is not aware that you are there. So something failed successfully. And with admin access to, or root access to account, to the organization management account, usually you have full access to all accounts in that organization. They were using organization with all features enabled, and they were not using the identity center, so the AWS SSO. So I enabled it for them. Before reporting to CISO, I enabled the identity center, created the permission set with full admin access, and created the native local user of the identity center. And I gave that user admin access to all accounts. So yeah, starting with non-prod environment of some Symfony app, I ended up as a full admin of the whole organization. Problems here, first and the biggest, production data on a non-production environment. If not the whole database, just the same passwords for administrators, it was enough. Because I was able to see the plaintext password of the admin of a non-prod account, a non-prod environment, and I used that to log into prod. Critical services using the same email address. This was also interesting because the webmail showed not only AWS-related emails, but there were also emails from Datadog and other services. And it was the email used for all of their tools. Yeah, I just got access everywhere. And there are two things I wanted to remember from this presentation. One of them is use MFA everywhere. And I used to say that with MFA, it's almost impossible to get in, it would stop me. But now I know that there are ways how to fool people into providing MFA tokens to attackers. So yeah, please use MFA, but don't get fooled on phishing sites to provide the code for the attackers. Next one. Do you guys use Kubernetes? Yay. And do you deploy Kubernetes in private subnets or public subnets? There's a lot of Kubernetes APIs control planes deployed in a way that I can easily access it because they are deployed in public subnets with public IP and no security on it. So any anonymous user can just go there with just the web browser. You can open your Chrome, Firefox, whatever you use, and type the IP /API/v1, and you are there. You don't need any tools, any special tools. You can check config maps, so contents of configuration files you use on your pods. You can check the pod list itself, what runs on that Kubernetes cluster, and you can check a list of all secrets. Secrets are encoded with base 64, so you can easily decode them. My tool shows me reports like that, so the list of pods with namespaces, I can try to find out what's there, if it's interesting or not. Config maps, so the contents of configuration files, already some credentials in there, and decoded secrets. As you can see, some database credentials and S3 access key, secret key for S3, but as you know, I'm not looking for data, I'm looking for full access. So the next step, I was looking at the list of pods. And one of the pods running there, one of the containers, was Jenkins. And Jenkins is the automation server. So if you use Jenkins to build your cloud, you usually give pretty high permissions to that Jenkins machine. And with Jenkins credentials stored in Kubernetes secrets, I was able to log into that Jenkins, but first I need to find where it is. There are a few ways how to do it. First of all, you can just check jenkins.example.com. Maybe that company exposed Jenkins to public internet. Or you can just forward port 8080 from that pod to your localhost port 8080 and go to browser, localhost port 8080, and you will have this app pop up in your web browser. So I logged in with the credentials from Kubernetes secrets, and if you have access to Jenkins on admin level, you can, for example, check workspaces of the projects that you have there. Workspaces are just the places where the code, when Jenkins fetches the code is, is stored in the workspace. You can go there and browse all the files in the project. You can also check Jenkins credentials, like something like a Vault or this similar idea, with the difference that with a one-liner you can get the values of all credentials there. If you don't have access to Jenkins scripts, but you can create a new job, just create a new job and print all credentials or put them in a file, and then you will go to workspaces and check the contents of that file. But still, no full access to AWS. From the workspaces, I found a config file with access and secret key that gave me access to S3 and SQS, still not admin. But in console logs, in build logs, in one of the projects, I found that it uses AWS CLI to communicate with AWS. So I decided to start bash, exec bash on that pod and get shell access, bash access on that pod with Jenkins, and just tested AWS S3LS to list S3 buckets on that account. It just worked because there was a role on that, either on that pod or the whole cluster, I don't know, I haven't checked. It was admin access. Problems here, the team that deployed that had no idea how networking works. Was the public subnet, was the private subnet, was the difference. And when they deployed that, they didn't even check if it's public or not, if it can be accessed. It worked for them, it was just a random IP, so who will find it? And also, there was a problem with penetration testing. They were performing penetration tests for production only, because it's cheaper. But this was a non-prod cluster, so why check something that is not production? We don't need that for our compliance. Just check the production and we're good. Nope. Disable security features. There was no role-based access control, the data was unencrypted, no firewall, anything like that. So with just the IP address, I was able to go there and browse the whole cluster, get whatever I wanted. The second thing I want you to remember, principle of least privilege. Please do not give admin for all. It's a very common scenario where a new team member joins and you want to give that person full admin access just because maybe they will need it in the future. Please do not do that. Scope permissions to the smallest possible permissions that this person needs to perform their job. And also running apps as root on the containers is a problem itself. There are better ways to run your containerized apps. There are some more scenarios. I don't have full slides for them, but let's go for them. Outdated software running on cloud resources. And as an example for that, there's Jira running on EC2. And Jira in a pretty old version, 7.3.3, that's somewhere around 2017. You can still find Jira versions 7.3.3 on the internet running today. And this version had a problem with one of the plugins. It was not only Jira, it was Jira Confluence, Bitbucket, Crucible, and something else, where you were able to use the tool without logging in, use the tool as an open proxy. And I asked the tool, there was an OAuth plugin, I asked it to open the metadata endpoint, 169.254, 169.254, and using this metadata endpoint, you were able to extract temporary credentials that the server is using, access key, secret key, and token. And I don't know why, but this Jira EC2 machine had full access to EC2s. So with access to EC2s, I was able to do whatever I wanted, like running a new EC2 and passing a role that was admin role and getting admin there. Next one, admin credentials logged during the installation. Again, this is Jenkins. I was asked to audit someone's AWS account. They gave me read-only access, so I checked that there are some EC2s in public subnets. One of them is Jenkins, but I don't have credentials to log in there. So I went through all services they were using. One service that they were using was CloudWatch. In CloudWatch logs, I found the full log of the installation of Jenkins, last lines. This is the login and password for Jenkins. Next one, misconfigured vhosts. If you use Nginx or Apache as your web servers, when you install them, you get the default vhost that is used when someone accesses your server by IP or by any other domain, subdomain that points to your server but is not configured with a separate vhost. And when you go there by IP, you see something like that, list of files. One of the files .env usually contains a lot of sensitive data, but there are other files that can give you access to more systems or that can expose someone's data. Then we have debug pages and debug pages with connection strings. This example is Python Django. They are doing a good job masking most of the sensitive details here. If they see that there's key or password or something else in the variable name, they mask the value. But hey, there's salary broker URL. No key, no password, but it contains access key and secret key. Guess what? Every single one I found gave me access not only to the SQS, as it's used here, but to more services. And with more services, you can try to get more and more access and escalate. That was the list of scenarios how to get in. But my next presentation is about staying there for a bit longer. Quick teaser. If you get access to someone's AWS account, you want to stay there forever and gain profit from different things. If you are a bad guy, so you can, for example, add another key for IAM users. You can modify trust policy for roles, allowing other hacked accounts to access this role. Or you can create a new identity provider. Then you can exploit public EC2s by, for example, adding a rule to security group, allowing you to SSH into that machine and maybe creating a local OS user that you can SSH into. For networking, we can just modify security groups. If the only security layer is a firewall, the security group, just add one rule and you're in. If you use some applications in your private subnets in your VPCs that communicate with each other with no authentication, and I create a VPC peering or attach a transit gateway to my VPC, I can access your network and talk to your applications as well. It's not AWS API access, but it's access to your data, and maybe one of the tools, one of the applications will leak something interesting. And the last one is the most complex and the most interesting. Use services that are not used in the project by the team. So, for example, if your customers are using IAM users and the roles and they are not using Identity Center, but someone gets access to their organization management account, I'm pretty sure they will enable Identity Center because it does not interfere with the current access model and it gives full access to all your accounts. You're not using code pipeline, but because you're using different CI/CD tools, that's fine. I will use that for you. I will create code pipeline and code build to build Terraform, and then I will integrate code pipeline with my public GitHub repository, or maybe not public, with my GitHub repository. Then I will push Terraform code to my GitHub repository, and every time I push the code there, code pipeline will see, okay, there's a change, it will be triggered, it will start code build, and I will build resources on your accounts by my GitHub repository. Or I can just create a Lambda that will restore all things in your account that you clean, and I will trigger it by public function URL. Then, self-healing. We can set a cron-like thing to rebuild things that you may find and remove. Or I can just have trigger on CloudTrail events that if you remove my backdoor, it will be recreated automatically. For detection prevention, when I play with your accounts and I create something, I don't create resources with full administrator access policy. Instead of that, I give that new IAM user or a role power user and IAM full. It equals the admin access, but sometimes it's not flagged on your super fancy security tools. And same context, that one is important because when I find your exposed EC2 and I'm able to extract temporary credentials from that EC2, and I use them from my Mac instead of that EC2, you will get notification in guard duty, hey, someone is using your credentials outside of the place what generated them. So instead of that, I'm playing with your AWS from the EC2 that I found. And office hours activity, that one is also important. I use search engines like Shodan Senses Binary Edge that scan the whole internet, IP by IP, port by port. So I already know what you have because someone scanned you before. And I know that I should just connect to this one endpoint. It's one request during your working hours, so it gets lost in tons of valid requests. And it's a bit different than all other attackers that are trying to hack your systems on Saturday or Sunday when no one is working. I try to do it in your working hours. And that was the last thing. Thank you. Do you have any questions?
I find it incredibly difficult to figure what faults you can do use, yeah. So just to have more than 3 roles, other than admin, developer, and something intermediate for the
Yeah, okay. So that's a very good question, how to stay sane configuring all these and all these granular permissions. For my projects, I have many different personas, like the DB admin, or the full administrator, or developer with access to Kubernetes, or read-only, or billing-only. And these are configured as permission sets on the Identity Center. And the Identity Center uses external identity providers like Okta or Azure AD with groups there. And I just define these personas, these roles, based on the needs of the customer. So first step, what do you really need? Oh, we need to be able to perform this and that. Okay, this sounds like the full administrator because you need access to IAM, the full access to IAM. Full access to IAM means you're an administrator. Even if you limit everything else, you can still do things that will give you full admin. But then, okay, we need only access to billing and read access to billing. Okay, there you need a persona for billing. And you scope all these personas and then try to give the permissions that you think they need and give them this access. Like for each persona, for each account, you have a group in your Okta, and they just put people there in this group so they can log in with correct permissions. And if they find an error, okay, you need one more permission to perform that, they will raise a ticket, hey, we need this permission added to this role because this person or this group of people are performing tasks that require them to do this and that. And then you modify it, you add things. Other approach would be to give them wide access and then look for all these activities they performed last month and then limit it, but I prefer the one when you give them as small permissions as possible and then maybe extend. Any other questions? Thank you so much for joining, and if you want to connect with me, that's my LinkedIn. I'll be happy to answer all the questions there as well. Thank you.